So yeah, I was building a zero knowledge airdrop tool. How do I present here? Um, so yeah, that's the link for the code. Obviously, you'll have it later. So the goals of it were to kind of replicate. There's a popular repo that A16Z crypto have where they're using like zkApp to do to prove that you're part of a particular address or public key data set, and also to claim and to prevent double claiming in a private manner. So yeah, I wanted to replicate this. It seemed like a good building tool that the community can use moving forwards. And yeah, I just wanted to kind of play around with zero knowledge contracts and kind of build something that's simple for people to use and understand. So yeah, what I thought, I'm going to go through what went well and then what didn't go so well. So first off, I thought it was super cool to be able to program like a smart contract, a zero knowledge smart contract in TypeScript. I mean, so yeah, like I'm a smart contract developer. Currently switching from Hard Hat to Foundry, but a lot of TypeScript experience, and I really admire the language. And like, yeah, I mean, obviously there are some pain points with it, but to not have to learn something new domain specific language, I thought that was awesome. The other thing that comes out of the box that I was impressed with was the permissioning, the signature or proof that you can set up in the initializer or deployer. And that's pretty powerful. A lot of the time in smart contract development, you end up pulling in OpenZeppelin libraries and writing lots of tests surrounding who can call what sort of functions. So it's cool that that kind of comes out of the box. And yeah, just having like all of the TypeScript tooling immediately available to you, or most of it, is very powerful as well. And it kind of doubles down or reinforces that it was a good decision to have this language as the implementation language. Even like, so I've been doing Solidity since I think 4.18, and it, you know, there was no, it was like programming a black box. So you had no console logging until pretty recently. So you just have that straight away, which is awesome. Yeah, I didn't make as much progress as in the actual implementation as like what I would have wanted, because I guess this is like what happens when you're working on cutting edge tech, but it's a lot of the errors. You have to go to like Discord or whatever, and sometimes they just get lost. The information, somebody had the same error as you, and then they get lost, or the solution gets lost, or it's not fully explained what how they resolved it. A couple of times I got some error messages that like had absolutely nothing to do with the error. So if, for example, this one over here was on an assertion, but then I don't know how it works, but the like where it was showing the error was just like completely unrelated. Another thing I found a bit difficult was that I was reliant on some of the libraries, in particular the Merkle Tree library, and the kind of APIs changed between the packages. It went out of experimental into the main repo, but again, you kind of have to expect these things to happen. And I spent a lot of time, and maybe this is my own fault, but I was trying to refactor it into like the way I'm used to developing smart contracts, which is a really test-driven approach. And there was a lot of kind of difficulty in kind of doing that. So yeah, just to jump straight into into what I actually did was so the way this program works is that there's a set of there's a set of addresses or public keys that you have, and you kind of condense them into a Merkle tree. You store the root of that Merkle tree in your zkApp. And then also to provide or to prevent double spending, I'm using the nice new MerkleMap structure, which is like a key value mapping that can be stored in a root. And that's to prevent somebody from claiming twice. So these are the main functionality that's kind of exposed to the user. So set commitment is a way to kind of initialize the data set. Check set inclusion is a user can come along and see if they're in the data set in a zero knowledge way. Check claimed is to see if they've already claimed, which just runs through the MerkleMap. So checking set inclusion looks at the Merkle tree. Check claimed looks at the MerkleMap. And then there's a claim functionality, which checks both the Merkle tree and the MerkleMap, and then transfers a custom token, which is also a cool feature that the ZK apps library or the smart contract library has out of the box that I only discovered recently. So you don't have to kind of create your own custom token. It's already built into the smart contract library. So yeah, it has the two functions then to mint that is kept by an administrator or whatever, and then to make the tokens transferable rather. So I don't know how much time we have, but I was going to just look at the contract really quickly. I think most of that has already been explained. So you can see here about the Merkle tree and the nullifiers. This has got to do with tokens. We have our deployment, we have our mint. Send tokens, as I said, is hitting the underlying token that every smart contract has. But if we're going to go through one method, I think the most interesting one is going to be claim. So there's a few things passed in here. Your account is basically your public key combined with a random nonce to give you kind of more privacy. This is the same way that A16Z were doing it in their repo. Then you have your path to the Merkle tree. So to prove that you're in the Merkle tree, a signature to, in order for the admin to, is this the admin signature? But the signature is for the minting, and the MerkleMap witness is to indicate that you're in that you haven't already claimed. So basically, yeah, you're just like asserting a load of things, as most I'm sure your programs do, and then updating the MerkleMap when it's done, so you can't double claim. And I actually for some reason couldn't get this working, but then you're going to mint the tokens to the account that's passed. So all of this code will be obviously in the link. So yeah, I would like to spend more time with this. I need to make it work entirely, but I didn't get around to doing a front end, which would be nice as well. But it's mostly kind of a back end project, but the front end would just include the ability to connect the equivalent of your MetaMask and check that you're in the set or in the airdrop or not. You can make it more flexible in terms of each user gets variable different amounts depending on whatever criteria that you have off chain, whatever business logic. Different destination address, so the ability to send the token or to mint the tokens to another address all under one step. The other repo that it's based off of has some convenience tooling in terms of just dumping a big blob of addresses or public keys in, and that would be handy. I think we need to look a little bit closer at the privacy constraints, I think it is private in terms of the inputs are privately generated, but obviously it needs some more security analysis, and also to see if this approach scales, which I think it does as well, but maybe there is some unknowns there. So yeah, thanks for listening to me blab on, and if there's any questions, I think we have 1 or 2 minutes.